Hi there. In the previous video I explained how to use a formula to factorize trinomials where the leading coefficient is not equal to 1. And let me just fix that again. That's not equal to 1. And I just want to do a few examples using that method. And you might recall, if you did watch that video, the formula that I give is 1 over 4a, and then in the bracket we have 2ax plus b minus the square root of b squared minus 4ac. That's the one bracket. The other bracket looks exactly the same, with the difference that this is, instead of a negative, it's a positive. So basically you just need to remember this expression and the 1 over 4 in front. And this one is 2a x plus b, and this one is plus the square root of b squared minus 4ac. There we go. And so what I'm going to do now is just use that to factorize this expression. First of all, in front of the bracket I'm going to have a 1 over, and then a, and maybe you didn't know that, but this is ax squared plus bx plus c. And now what you notice, so a is equal to 2, so 1 over 4a means it's 4 times 2, so this is 1 over 8. And then in my first bracket, let's work out the 2a, so a is equal to 2, so 2a is equal to 4. Then that's 4x. The next part of the expression, we have to calculate this expression. So since we're using this square root twice, let's just work out the interior of the square root first. The interior here is b squared. Now b, you'll notice in here, is -1. It's the term in front, the factor in front of the x, -1. When I square that, I get +1. Okay, minus 4ac, so 4 times a, that's 4 times 2 is 8. And then 8 times 15 is, what's that? 4 times 15 is 60, so it's 120, but it's -15. So this -4ac becomes positive 120. And so the whole expression is 121. And this expression can only factorize if that answer that we get is a perfect square. In other words, when you put it in a square root, you get a perfectly whole number as an answer, and in this case it's 11. The square root of this, I mean. So the square root of these is 11. Now I'm going to use it in both brackets, and that's why this method is actually quite simple. It's the only really complicated step is calculating that square root. Okay, so what we have here is we have the b, which is -1. So -1 minus 11 is -12. So minus 12. There's my first bracket. The second bracket would look exactly the same. The only difference is, and be careful not to make this now positive 12. What becomes a positive is what we got in the square root. So instead of subtracting 11 this time, we're going to add it. Okay, so we're going to add it together, and now we get -1 plus 11 gives me 10, plus 10. Now we're not done yet. The last step in this method is to get rid of the 1 over 8. In order to do that, I need to take out common factors from the terms inside the bracket. So for example, one value you must always be able to take out is the a. So in one of these two brackets, we should have 2 as a common factor. In this case, we can see it actually as both. But basically, all you can do is take out the biggest, the greatest common factor. In other words, just factorize the brackets itself again. And here we see we can take out a 4 as a common factor. So if I do take out a 4, I'm left with 1 over 2. And here I can see I'm taking out a 2 as a common factor, and that will leave me, so I've taken out a 4 from here, and I'm going to take out a 2 from there. When I take the 4 out, I'm going to be left with 4 goes into itself once, into 8 twice, so I'm going to be left with a half. Then when I take out the 2 will cancel with the 2, so I'll be left with 1 in front. So this is literally what's going to be left if I take out these common factors. So if I take it a 4, I'm left with x minus 3. And here if I take out a 2, I'm left with 2x plus 5. And there we go. That is exactly factorizing that. We can test it if you want. So x times 2x is 2x squared. Negative 3x, negative 3 times 2x is negative 6x. Plus the 5x gives me negative x. Negative 6 plus 5 is negative 1. Okay, and then finally the negative 3 times the 5 gives me the negative 15. Now there's a way of doing this very quickly, sometimes just by inspection, just by testing a few numbers, but I do think this is a very simple and foolproof way of doing the factorizing no matter what size the values are or how many factors there are in front. It always takes the same amount of time to actually do this question. So I will do in the next video, I'll do another example, maybe slightly complicated. I'll see you there.